Is it live? 1 minute. I think it's live. Yes. Hey guys, you can chat. You guys can chat, right? Yes. So, welcome back to Varshini's Edu app. This is Varshini Murli, and yeah, I can see some of them. One more Varshini is chatting there. Hello, Varshini, and yeah. So, yes. You want to- Okay. I'm fine, dear. Thank you so much, Varshini. Really fine. Yes, and today we're starting with a new chapter. Actually, I thought like we don't want to continuously make it as math, so we want let us like keep it as another subject. So yeah, so here we are at the science subject. Science. Sorry. Yeah, we are at the science chapter. Combustion, flame, and fuels. Combustion, flame, and fuels. We're going to look at that chapter today. So, yes, grade 8, class CBSE slash NCRT. Okay, let's move on. Okay, combustion. Combustion is defined as the process of burning of a substance in the presence of air or oxygen with the liberation of light and heat. So, combustion is nothing. I'm fine, dear. I'm fine, Vashini. Thank you so much for asking. Yes, combustion is nothing but like when a substance, any substance, with it is burning with the presence of oxygen, air or oxygen, and it gives out heat or light. The result is heat or light. So this is the process is called as combustion. And combustion is a chemical or physical change. Chemical or physical change. Students, I know you can type your answers in the chat, right? There is live chat. Yes, Vashni, right. It is chemical change. Yes. I don't know why you're not typing. Yeah, it's okay. I think the live chat is open for all of you guys. Okay. Yes, it is a chemical change. As you can see some images below. So it is a chemical change. Okay, let us move on. Now, combustible substances. So, the combustion can be divided into combustible and non-combustible substances. Now, combustible substance is nothing but the substance which burns to produce light and heat. Means like it catches fire easily. Okay, so when a substance is there with the presence of oxygen and it gives out heat or light is called as combustible substance. Substance which catch fire easily. As you can see here, some examples: paper, when wood, kerosene, and LPG. So you can see paper when you some of them you might by mistakenly put paper on fire. I think when you guys are really small and all, you must be doing this. You might see it turns into a ash color, right? So that is, it burns on fire. And even LPG and kerosene, petrol, diesel. So these are the examples of combustible substance. But if you see non-combustible substance is nothing but it's the opposite of combustible substance. It does not produce any light or heat like water, sand, glass, and cement. Okay, that is the opposite of non-combustible substance, which does not produce any heat on burning. Okay, now let us look at the conditions which are necessary for a combustion. What are the conditions which are necessary for a combustion to take place? First thing, as you can see, there should be a supporter of a combustion. First thing, it should be a combustible substance. It should be a combustible substance. Then only combustion can take place, right? Yes or no? Yes. Without a combustible substance, it cannot take, combustion will not happen. So yes, that and supporters. Supporters are, the most commonly supported is the oxygen. Oxygen supports a substance to take place of combustion. That's basically oxygen. But if you say other gases like carbon dioxide, nitrogen and all, these are the non-supporters of combustion. They do not support combustion. But oxygen, it does support combustion and heating. And also it should be an ignition, presence of ignition. Heating should be in an ignition temperature. Ignition temperature is nothing but low temperature. It is in low temperature. It should be taken place in a low temperature. Yes. As you can see, the meaning is here. The lowest temperature at which a substance catches fire is ignition temperature. As you can see, some matchstick and wood on fire. So it is nothing but ignition temperature, where it's a low temperature. A substance which catches fire in a low temperature is nothing but ignition temperature. Let us move on to the next, this one. One minute, students. Fine. Okay, thank you. Yeah, sorry, students, there were some network issues, I guess. Yeah. Now, ignition temperature in different materials. As we all know that ignition temperature, it is different from materials. All materials does not have the same ignition temperature. For each material, there is different ignition temperature. But if you see some examples we're having as white phosphorus, the ignition temperature of this is 35 degree. Petrol is 246 degree. Kerosene is 220 degree. Diesel is 210. Wood is 300. Coal is 454. And piece of paper is 233. The highest, the maximum is 454, which is the coal. 454, which is the coal. And the lowest is white phosphorus, which is 35 degrees. Types of combustion. Now, types of combustion, we looked at combustible, non-combustible substances. That is about their substances. But if you see here, let us look at the types, the three types, which is the rapid combustion, spontaneous combustion, explosion, and slow combustion. So we will be looking at these all in detail. Rapid combustion. Okay, rapid combustion is like nothing but the combustion, it takes rapidly and produces heat and light, is called as rapid combustion. Okay, So example, burning of white phosphorus at low temperature. At room temperature. So rapid combustion is nothing but a combustion. The combustion in which a substance takes place rapidly, and it produces heat and light. Instead of white phosphorus, can we give any other examples? Yes, we can. Example, we can say LPG and burning of a matchstick. Burning of a matchstick, isn't it? You might when burning of matchstick, when you are doing puja or something like that, you might see, right? The matchstick, it takes combustion rapidly and produces. Yes. So that is basically rapid combustion. Now spontaneous combustion. Spontaneous combustion is nothing but a combustion in which material suddenly bursts into flames without the application. It's like unexpectedly. Spontaneous is nothing but unexpectedly, without knowing. Okay. Without knowing, it happens. Unexpectedly is nothing but without knowing. Okay. So it is without knowing, the combustion takes place without knowing. So that's basically spontaneous combustion. Like if you see, what do I say? Sodium and sodium is a really high reactive metal, isn't it? So when it just unexpectedly, it will, with the presence of oxygen, it will burn, isn't it? Yeah. So that's why what is it suggested? It is suggested to keep. What is it suggested, students? Come on, type your answer in the chat. Let us see who can say. Why is only Varshini typing? Yes, you're correct, Varshini. It is stored in kerosene. That's what it is suggested to store in kerosene, so that it cuts off the supply. Next is spot. Examples, we can say. Examples is forest fires, um, combustion of coal mines. Now explosion. So students, I think I didn't mention here the slow combustion, isn't it? Okay, 1 minute. Wait. I will tell what is slow combustion. Slow combustion is nothing but by the word slow itself you might understand, right? Slow means it takes slowly. The process of it takes really slow. And some examples of the digestion. The digestion of food. The process of digestion of food, it takes really slowly. That's the slow combustion. It's taking really slowly. That's basically slow combustion. Let us move on to explosion. Explosion is nothing but when you see crackers. So as you guys don't know that Diwali is also coming at 14th, right? Diwali. So you might be burning crackers, and also we can see that as an example of explosion. And bomb also. Bomb. I'll write here. Bomb. Bomb also is an example of explosion. Explosion is nothing but which produces a sudden reaction which produces sound, heat, and light. Is called as explosion. Example, burning of crackers and bomb. So substances which give out flame. Now flame, that is different. Like burning, heating, and all that is different. But this is something which talks about only flame. Okay, the meaning of flame is when they vaporize during combustion, like kerosene, wax. Wax, you know this candle, right? In that it has wax. The wax melts, and due to that, the burning of it vaporizes and produces flame. That is basically wax. Candle flame. So let us talk about the parts of candle flame. We are having the three, which is the outer zone. I'll just use the colors so that it outer zone, middle zone, and innermost zone. We can tell these in different ways: non-luminous, luminous, and dark zone. Okay. Now goldsmith. Goldsmith is where we are using the outermost zone in a flame with a metallic. Can you see this person? He's melting the gold and silver using the metallic blowpipe. So that is basically goldsmith, which is used in which zone of the flame? The outermost zone of the flame it is used. Now inflammable substances. Substances which has low ignition temperature. Ignition temperature which is really low and it burns easily. It catches fire easily. That substance which has low ignition temperature and catches fire easily is inflammable substance. Petrol, alcohol, LPG, full form is liquefied petroleum gas. Okay, so these are inflammable substances as it has low temperature, low ignition temperature, and it can catch fire easily. Okay, next we are seeing how can fire be extinguished. What is fire extinguisher? It is a portable apparatus which is used to put out fire, isn't it? Yes, it is. It is used to put out fire. Now, how do we when we look at how do fire can be extinguished? In what ways it can be extinguished? By we remove the combustible substance. When the combustible substance is burning, we can just remove it like fuel. Cutting off the supply of oxygen, yes. As we know, with the combustible substance and it reacts with oxygen, it starts burning. So when we cut the supply of oxygen, there will not be any support for combustion and combustion will not be able to take place. We also can reduce the temperature of the fuel by its ignition temperature. So these are the three methods which you can do for fire which can be extinguished. This is the same thing, cooling the combustible substance. This is what we have just learned now. Now fuels, what are fuels basically? Fuels which produce heat and light on burning is called fuels. Fuels can be classified on their source: solid, liquid, and gaseous. Okay, solid fuels is which are in solid state and room temperature. Okay, and they need large space for storage, like wood, charcoal, cow agriculture waste, etc. Liquid fuels is in liquid state. As you can see, by solid, liquid, gas itself, we can understand each and every fuel at its liquid, solid, or gaseous state. But all of them are in room temperature. As we can see, all of them are in room temperature. Okay, example: kerosene, petrol, and diesel. Gaseous is natural biogas, petroleum gas. So the difference between is solid fuels exist in solid states, liquid fuel exists in liquid state, and gaseous fuel exists in gaseous state. And all of them are in the same room temperature. They are not in liquid. temperature, they all are in room temperature. Okay, so examples are also different. Here in solid we can see charcoal, wood, and liquid we can say kerosene, petrol. Gaseous is natural gas and petroleum gas. This is the same thing which we have looked now. If you see the examples here, solid, liquid, and gaseous. Liquid fuels we can see petrol, diesel, solid, wood, charcoal, gaseous. Now calorific value. This is most important of this chapter, calorific value. Calorific value is the amount of heat which is being produced on 1 kg of fuel. Okay, complete combustion. Complete combustion, what is complete combustion? Complete combustion is nothing but combustion which takes place with a sufficient amount of oxygen is complete combustion. Okay, that is called as calorific value. And what is the unit expressed in unit? Kilojoule per kg. Kg L slash kg. I mean kj by kg. And the SI unit of calorific value is what? It is, who can say? Yes, it is kg. Got it, Varshini. I got it. Thank you. It is kg. Yes, you're correct. Yes, calorific value of is kg. SI unit is kg. Yes, this is what we have just learned now. Now, ideal fuels. Characteristics of ideal fuels means it has high calorific values. It should be high. If they should be, how do we describe that? Is it a good fuel or is it a bad fuel? So that fuel should be in a high calorific value, moderate ignition temperature, low cost. It should be easy to storage and transport and should not produce any harmful gases. So I'm just circling the important ones which you guys need to learn. High calorific value, moderate temperature, should not produce harmful products or harmful gases, and easy to storage and transport. Also easy to control. That's also fine. As we can see, hydrogen is having the highest calorific value. Okay. It does not pollute any, it's non-polluting. Okay. And hydrogen is the most one, it is having high calorific value. It is used in spaceship or any high temperature flame. It is a really high temperature flame. So guys, I don't wanted to make it so complicated for you all. So this is just the L1, meaning the part 1 of combustion, flame and fuels, because there is two disadvantage. I will not be able to teach you whole chapter in one day. I don't think so. You guys maybe not being able to you understand. I guess you'll not be able to it'll be all complicated for you guys, isn't it? So yes, Varshini is saying yes, ma'am. Yeah. So it will be really complicated for you all to study the whole chapter. So till now what we have studied, you can revise it. So you can also watch the video again if you're not in the live stream. So yes. So guys, I'm going to end the video right here. So I hope you like this video and do not forget to subscribe to my channel. I'm writing the name of my channel right here so that Varshini's Edu app. So I am Varshini Murli, and yeah. So this is my YouTube name, Varshini's Edu app. If you think this video is really helpful and if you think that it is really well explained, means please do not forget to subscribe to my channel and click the notification bell button so that you might know that you will get the notification that when we are live as well as when we are uploading a video. And do not forget to comment also. If you do not forget to comment if you have any doubts regarding this chapter, combustion, flame and fuels, or any other chapter. I will be surely there to help you guys. So this is Vaishni Muli, and I will see you. And I'm going to end the video right here. And I hope I will come back next time. I will be teaching you again the continuation of combustion, flame and fuels. So yes, I'll just end the video right here. I will see you next time. Bye. Bye dear. Bye.